Hello everyone, welcome back to my channel. In this video I want to show you or go over how to create and join a Kubernetes worker on an existing Kubernetes cluster. So I currently have a cluster with one master and three nodes, which I configure all at the same time. And I got to thinking, it's like, okay, what if I want to add a new worker to the cluster? Instead of doing it by hand, because if I want to join one now and then another one later and another one, I thought, okay, let's go ahead and automate this process using Ansible. So I already went ahead and did that. But let me show you. So if you were to do it by hand, you will have to. Actually, let me hold on. Let me exit out of full screen here. So you will have to. These are pretty much all the steps you will have to do uh, from if you're running bash commands. You will have to disable swap, remove it from the etcfs tab. You have to set up some different modules, mod pro overlay, the bridge net filter, install containerd, do some configuration files, edit this file, install Kubernetes. So as you can see, there's a lot of steps that you have to do. For when you're adding a new worker. So I actually went ahead and did all these steps and recreated them using Ansible. So that way, in the event that I want to join one worker, two workers, or more, or multiple ones, I can just go ahead and do that. So let me show you my Ansible environment real quick. So I have roles, my playbooks, my inventory file. So my inventory file consists right now is just my cluster. So I have a control node. Then these are my workers 1, 2, 3, and 4. These three are already part of the cluster. This is the fourth one that I want to join to it. And then if I want to run a playbook against everything, this is how I will do it. So now I want to make sure that I'm able to ping all of them. So if I do Ansible ping, if I do Kubernetes cluster, I should be able to ping all of them, which tells me I should be able to run Ansible playbooks against them. Okay, so 4 is unreachable. Okay, I believe I need to copy my keys over to it. SSH, copy keys over to Kubernetes 04. Okay, so copy my keys. So once I copy my SSH keys, I should be able to do it now. So if I rerun that command, ansible-m ping, so I can ping 4, I can ping 3, 1, I can ping 2, and the master. So that means every node is accessible from Ansible. So here's my setup. So obviously here's my main Ansible setup, my Ansible configuration, my inventory playbooks. As you can see, I already added the main playbook that's going to call the roles add Kubernetes node files. I've created 2 templates that I'm going to go over real quick in just a minute. And this is the main file under task. This is where all the tasks that are going to be executed against my target host are being called from. So if we go over to that, so if we vim roles add task main. So like I said, I already created this. I thought about going over it, as I was typing all this, but I felt like it was taking way too long to go over it. So I'm gonna try to explain it real quick. So the first task, obviously, I always do a description. First task, basically, on just disabling swap from the current session. There's no module for, so we'll execute a command with swap off -a. That's the same as you will do with the bash on the bash command line. Then I go ahead and remove swap from etcfs tab. That's where all your file systems are. So I'm using the mount module with items. So when you're using item variable, you tell me, okay, do this, look for a file type swap, make sure it's absent, make sure it's not there, and then loop through these items. So this is what it's doing. After that, then I'm setting up the kernel modules and cctl. So here I'm using a block because all these tasks are somehow tied together. So I'm creating the Kubernetes module load file. This is the template that I'm creating. So I'm going to show you what that template looks like. If I split my screen and I go over to roles, add templates. So those are the two templates that I created. So we're looking at modules Kubernetes. So Vim modules Kubernetes conf Jinja 2. That's it. It's nothing crazy. We just need the overlay, and this is for the networking part of Kubernetes to work. Overlay and the bridge net filter. So that basically that prepares Linux networking so Kubernetes networking works correctly. Nothing crazy. Same thing with and then we go and load the overlay module, and we load the bridge net filter module. That's what these two tasks are doing. So that's that guy. And then we also have the cctl template, which we're doing right here. We're creating that template. We're calling this file right here, and we're creating it in this destination on the target host. Then we're setting the bridge NFS call, which is this right here. Okay, we're setting it to present with the value of 1, which means on, and we're telling it, okay, here, the system file. Then same thing, we'll set the IP forward, which is this guy right here. We're enabling it, we're making sure it's enabled, value 1, the state present, make sure it's there, same thing. Then we go ahead and disable, well, we set SLinux to permissive, so we're setting the permissive option in here. We're using the SLinux module, policy targeted, state permissive. So that's how you set it to permissive. Then, let me make this bigger. Then I'm using the get URL module to download the Docker CE repo. We're using the URL attribute. This is the link to it. The destination, it goes over to etsy.repos.d. It creates a docker-ce.repo file. We set in the permissions, honor, root, and mode. I have a typo in here. Get rid of that right there. Save it. Then once we have the Docker repo installed, configured, so now I'm gonna install a package for containerd.io. So that's what this is doing. So I'm using the DNF module, and I'm telling from run DNF and make sure that containerd.io is present. So that's the equivalent to DNF space install containerd.io -y. So that's what we're doing here. Then we're creating containerd directory. So we use the built-in file module. We're telling it, okay, I want to make sure the Etsy containerd directory is present. With the state, we're making sure it's a directory instead of a file. We're setting up the permissions and the owner, the group. From here, we create the default containerd configuration. We're using the command module to run this bash command, which is containerd config default. This generates the default file, and then we're saving it to a variable named containerd_config. So now that we have this output, the output of this command saved to this variable, now we're going to write that into a file, which is what we're doing on the next task. We're using write the config file, the config to a file. So the content, we're calling this variable, the containerd_config standard output. We're calling that that variable, and now we're telling, okay, write that to Etsy containerd config.toml. Again, we give it the owner, the group, and the mode. We'll do notified restart containerd. So if this changes, then we're going to notify another task, a handler that's going to restart or enable the service. Then we go into this file, the config.toml file, and we make sure that this line is present and that it's set to true. So we're using the line in file module, and we're telling, okay, go look at Etsy containerd config.toml, look for a line that starts with systemc group. The caret symbol right here means the line starts with that, and set to false, and then okay, replace that with systemc group equals true. So that's the only change we're making to this file. I guess this file right here, we're replacing false to true. Once that's done, then we're gonna enable and start container D, and that's what the service module is doing over here. We'll say, okay, look at the service, the name of the service container D, make sure it's started, and enable it. So that's the equivalent to systemctl enable space dash dash now container D. So that's what this is doing. Now we go and configure the Kubernetes repo. For this, we're using the yum repo repository module. We're giving it a name, a description, then the base URL for the repo. We're making sure it's enabled. We want to enable the option to check for the key, for the GPG check key, and then we'll give it the URL for it too. Once we have the Kubernetes repo configured, now we're installing the packages that we need from it. So we use the built-in DNF module, and we're telling, okay, install kubelet, install kubeadm, and install kubectl, and make sure they're present. Why present instead of latest? So if the VM or your target host where you're running this on already has these packages installed, it's not going to try to reinstall them because they're already there. But if I was to change this to latest, then yes, it will try to reinstall them and override them, but we don't want that. So that's a good option. Then we go ahead and enable and start kubelet. So once we install kubelet, we call again the service module, and we tell, okay, look at the kubelet service, make sure the state is started, that is running, and that it's enabled. So every time you reboot or restart the system, it comes up by default. Now here we're dealing with firewall rules, firewall D. We're like, okay, Kubernetes traffic, there's certain not IPs, there's certain ports that we need to make sure that are enabled, that are open, or allowing traffic. So instead of ports, if we're using multiple ports, we're going to use an item option, which is a variable placeholder. We're saying, okay, permanent true, meaning yes, dash, when you use a firewall dash cmd command, dash dash permanent, that's basically what this is doing. Immediate, this is the same as firewall dash cmd reload. That's what this is doing right here. State enable. And then this item right here is going to loop through this option. So it's going to loop through 6443/TCP, and then it's going to run all these flags underneath it. And then it's going to do the same thing for these ports numbers right here. Then we go at the very end, and we have to actually generate the token from the master to capture that token and run it on the worker, on the target host, to join the cluster. So what we're doing here, we're creating another block. We need to generate the command on the Kubernetes master, and this is the command, the kubeadm token create. So normally you will run this on the master and then copy it and paste it on your host, on the worker. But what we're doing is, okay, we're taking this command, we're saving the output to this variable name, join underscore command underscore output, and we're delegating just this task. We're delegating this task to Kubernetes master. This is the host name. Make sure that this host name is reachable. If you remember at the beginning of this video, I ran the ping command, the ping module, the Ansible ping module against all my Kubernetes VMs, and I was able to say, yes, I can ping it. So make sure whatever your master is, you're able to get to it, because you're running this task against that host. And then we take the value of this variable. We come in, now we want to join it. Now we want to run it on the actual target. So again, we run that command, the join underscore command output, send the output against our target host, and then it joins it. And we want to make sure that this file is there already. So that's basically all the tasks that are needed for joining a new host to a cluster. Let me show you what the handler is. So if I go rules at handler main, so basically what that's doing is just has a separate task to restart container D. So in the event that container D, that changes, then it calls this task, and it makes sure that that state is restarted. I don't think there's anything else under roles. But then if we look at the playbook itself, so now the playbook, so I'm giving it a name, configure Kubernetes worker node, host. So in this part, I'm actually setting it to a variable. So that way, in the event that you want to target one host or multiple hosts, you don't have to keep coming over here and editing this file. You're actually going to be prompted over here for the host name. And I'm setting it to false, so that way you can actually see what you're typing. If you set this to true, then you won't see anything when you're typing. This is a good option to set it to true is when you're typing a password and you don't want anyone to see it. And the prompt is just what you're going to see on the screen. Enter target host. And the name, which is host name, is this same host name variable. And then at the very end, roles, we're calling the add Kubernetes node role, which is what we were just looking at. It's this right here. So we're calling this role. And then from there, Ansible knows, okay, let me look at task. Under task, let me run main file. If the main file has any handlers, then main file calls the main file under handlers. Also, the main file knows that it has templates. So when we are defining these files, these Jinja 2 files, it knows the main file under task knows, okay, let me look at templates and let me pull those templates from there. So it's going to call these two. If we would have set some variables, it would have called them from here. Defaults, they're also variables. It would have called them from here. If you had files or some other stuff, then the main task would have called them from here. And that's the beauty of the main reason of using roles. You're able to organize your files better instead of just having one playbook. Because I could have done everything in here in the main playbook and had everything from the task main in here, but it would have made the file way bigger. It's just not recommended when you're running multiple tasks and you're calling files, templates, you're calling handlers. It's a lot easier to use to do this one at that point. All right, so enough talking. Let's go ahead and run it now. Before I do, I want to make sure that there's no syntax errors. So let's check for syntax errors. So we're going to do playbooks, add -- syntax check. Make sure there's no typos or anything else. So far it checked out, so that's good. So let's run it again. So now we're going to run it without syntax, but we want to be prompted for my admin password. If I was to do lowercase k, that will prompt it for my regular user password. Uppercase K will prompt me for become my sudo password. Okay, so let's do that. And actually, before I do that, actually I need to delete that, but let me show you real quick. So if I SSH to my Kubernetes master, I do kubectl get nodes, kubectl get nodes. You see I only have my master, which is the control plane, and 3 workers. So we'll see once I run this. Then we should be able to see a 4th one. So let me exit out of this so I can just expand the screen. Let's run that. Become, then I need my sudo password. There's the variable prompt. So which is going to be Kubernetes node 04. Okay, now it's configuring, it's calling the play. It's gathering the facts for these hosts. And now it's going through all the tasks that I created in the roles task main.yaml. So it's going to go through every single one of them. Hopefully I don't have any typos of any issues. And every time you see a state change, that means that particular task was changed or was implemented. The target host was not in the task that you wanted. Every time you see something that says okay, that means okay, that task is already in the state that you wanted. So Ansible is not making any changes; it's just keeping it the way it is, which is good. You're not overriding or overdoing something if it's already in the state that you want it. All right, so I'm gonna let this run. It's probably gonna take a few minutes. I know there's a few packages that take about a minute or so. So I'm gonna mute myself for a little bit. I'm gonna let this run. If there's any hiccups or errors, then I'll come back and I'll try to fix it or explain what happens. If not, I'll see you at the end of this playbook once it's done executing it. Okay, great. So it finished. We can see that there were 19 changes out of 29 tasks. At the very end, that handler that I explained, it restarted container D, which is good. Nothing failed, nothing was skipped. So that seems to have been a success. So great. So now imagine having to run this or running this on multiple systems at once, and just run it and you forget about it. Instead of having to do all these steps, by hand through the command line interface. This saves you time. It saves you from having typos, human errors. So let's go ahead and check the cluster now. So if we do SSH Kubernetes master, now I should be able to see that node. There we go. So we see a Kubernetes node 4 now is being added and it's being up for 66 seconds. Okay, so let's test this. So why do we want to do this? So if I do kubectl get pods, I have 3 pods running right now, and I know they're running on 1, 2, and 3. So if I do -y, yep, I can see my pods are running on Kubernetes node 1, Kubernetes 2, and 3. And these are just Nginx pods. But now, since I have a 4th worker, let's increase that. So if we do, I'm gonna edit the my web test YAML file, which is my manifest file. So you can see right now the replicas are set to 3. So if I increase that to 4, that should force it to create a new pod, and it should add it to the 4th worker that we just added. So now we want to do kubectl apply -f. We'll do that. So that applies that new configuration. And now we'll see. Okay, so now as you can see, it's creating that new container and, well, pod. And it's adding it to the 4th node. And that's exactly what we want. So it's still creating it. We'll give it about a minute or so. It shouldn't take that long. That's still creating it. Okay, so it should be good now. I didn't know how the video paused, so I'm not sure how far back I went. So yeah, so the where was I? The worker was added. So if we do get pods or get nodes, so we can see master 1, 2, 3, and 4. Then if we do get pods, we can see that now the worker 4 has been added. Kubectl get pods -o wide. Then we got 4 different pods running, running on 1, running on 2, 3, and 4. As you can see, this one's been running for 4 minutes and 7 seconds, which is the time frame since it was added. So again, that's the beauty of running Ansible. It allows you to automate a process, and once you have it set the way you want it to, you can just run the playbook on one target host or multiple target hosts, and be hands off, and make sure that everything is in the state that you want it to be. So I hope this was useful. I hope you liked it. If you have any questions, feel free to leave questions or comments. Don't forget to like the video and join the page. Thank you and have a great one.